Okay, so first thing we want to do is we're having a little look at how the water and carbon cycles are interlinked and interdependent. Okay, so what we want to do is take the information that's in table 4.16 at the bottom of page 131. That information is also within this PowerPoint on the slides preceding this one. Okay, and we want to see how we can apply it to this concept map. So we just want to sort of take that information and see how we can put it into this format. Okay, so we've got an example here going between soils and vegetation and the atmosphere. Photosynthesis takes CO2 out of the air and leads to water entering the atmosphere. So other things that we might think are up here, we might have, say, CO2 in atmosphere diffuses to ocean, increasing acidity, which is affecting the water cycle because it's making that ocean store more acidic. We'll see shortly as well that acidity can affect the amount of photosynthesizing that is being done by things like phytoplankton. So that would be another link between the two. So what we want to try and do on a sheet of A4 or A3 is put these terms in the corners and see how many links we can make. Now, some of them are going to certainly have a lot more going on than others. So CO2 entering the atmosphere causes effects all over the place. So CO2 in the atmosphere causes changes to the cryosphere. It's things like melting of the cryosphere. You can then link to the oceans by thinking about how melting of the cryosphere affects the ocean, things like that. So that's going to affect sea level. And we want to try and put together as many as the points that we can from that table onto a sheet like this, so we can see how they all affect one another. Okay. So, human activities causing change in the water and carbon cycle. So this is a sort of little specific bit that we've got to cover, though actually we cover how humans affect the stores in the water and carbon cycles throughout this topic, but we've got a couple of specific examples here. So just to start us off, we've had a lot of rapid population growth over the past 100 years or so, and that's caused major changes in the water and carbon stores and the rate of transfers between these stores, particularly at sort of local and regional levels, as well as globally. So, first example we just want to have a look at is how humans affect the water cycle on a local scale. So this example on the right here is where somebody, this could represent a town, is drawing water out of an aquifer. So we've got the aquifer down at the bottom, and they've drilled down to the aquifer and they're pumping water up. Key thing to highlight is that this is close to the sea. So what happens in this situation is if you're only pumping a small amount of water, fine, you're just going to keep pumping fresh water, and when it rains, new fresh water will recharge the aquifer. But as you draw water out, particularly if you start to what's called over pump and draw too much out, is you create an area of low pressure around the bottom of the borehole. That means that the relatively higher pressure water around it will be drawn to that point. It will diffuse to that point through the aquifer. And if you keep drawing water like that, you're going to end up with this thing called saltwater intrusion. So the salty water that's in the aquifer close to the sea over here is drawing towards the borehole because of the reduced pressure created by pumping the water out. So this is happening because we have such a high demand for water for things like irrigation, things like domestic usage. So we use so much more water in our homes than we did in the past. Things like toilets and showers and washing machines and things all are heavy users of water. We also use a lot of water in industrial processes, so things like cooling machinery and things like that. So this example is quite prominent in Bangladesh. So they're quite close to the sea. There's a lot of people living in coastal regions in Bangladesh, and there's a very high population. So they're pumping water out of the aquifers, and the aquifers are ending up contaminated with the salty water, meaning that they can't be used for drinking water anymore. Another way, this is separate to the example here, that we're affecting the water cycle on local scales, as we've learned about previously, is through things like deforestation urbanisation, things like this. This affects things like runoff, through flow. It lowers the water table generally. Okay. So I just want to look here at an example of the sort of thing we can be given in an exam. Okay, so this question, what are the limitations of this data presentation? First of all, very important, it's the presentation of the data that we are discussing limitations of, not the data itself. We will have a look at that shortly, but for now, this is the question we're being asked. And make sure that when you ask this question, that is what you're answering. Not the limitation of the data, but the presentation of the data. Okay, so this type of map is called a choropleth map. You can use these in your coursework as a sophisticated data presentation technique, which is good for getting into the higher grade brackets. So first of all, you can have a little think yourself, pause here and think, what do you think the limitations of the presentation are? But first of all, big one with these choropleths is abrupt changes. Okay, so if you look at the borders of these countries, so here we've got Russia and Mongolia, we've got a distinct change happening. We've got a major shift between as we cross that border. And particularly with physical geography, there's an argument to be made that it's not like as you walk across that border, instantly things change from one thing to another. Now, you could argue with CO2 emissions that is often a kind of country by country thing. So in some countries they may be much higher emitters because they're wealthier than other people, but I think it's a fair point to say that the abrupt changes probably are not actually representative of what's happening in real life. Abrupt changes is a particularly relevant point if, say, you were looking at something like precipitation, because that's a completely natural process. It will not change abruptly just because you're crossing from one country into the next, unless something like you were crossing a major mountain chain, in which case that could cause a bit of a change. One thing to look out for is when you talk about human geography, abrupt changes can happen more commonly. So say, for example, you were looking at life expectancy or infant mortality, and you were going from a country with brilliant healthcare to a country with very poor healthcare. Well, there we could see an abrupt change as we crossed from one side of the border into the other. On a similar note, sort of overgeneralization. So what I mean by that is if we have a look over here at America, population of over 300 million people, and they're all being generalised with the same figure, basically. They're all being treated, all those people in that per capita area are being treated as though they emit the same amount of CO2, when in actual fact it might be that some states emit huge amounts and other states emit a lot less. So, and then if we look, because of the nature of countries and populations, we've got examples where we've got data representing for much, much smaller countries. So like say here in Central America, much smaller populations, and we're getting accurate data for those individuals. So it's not a very sort of fair way of representing people's data. Something else to look out for with these sorts of questions always is things like the key. This key isn't too bad. There are some limitations. So first of all, you might notice that the increments are a bit odd. We go sort of 0 to 2, 2 to 5, 5 to 10, 10 to 30. And there's not even a real logic. It's sort of more forgivable if, say, for example, maybe it doubled each time, something like that. So if the gap between them, then it would actually have a certain logic to it. But these just seem to kind of go up in whatever increments they sort of feel like. It also ends at 60. Does that mean that 60 is actually the highest number? Are some countries actually higher than 60? We don't really know necessarily. Commonly with these, it might sometimes just the final colour is sort of say like 30 plus, and that's a big limitation you can point out, because 30 plus, well, a country could be like 1 million and we wouldn't know. This one isn't too bad in the sense that these are actually what we call like discrete separate colours. You could actually properly identify which category each country fitted into. Sometimes these are just a sort of a bar of colour that shifts gradually from one shade to another, and that makes it very difficult to identify the amount that a country is emitting or what have you. So that's a good limitation that you can sometimes make reference to. Okay, so like I say, it's very important that you identify whether or not you're talking about the limitations of the presentation or the limitations of the data itself. So now we'll just talk about the limitations of the data itself. So if you're actually, I'll cross out presentation, if you're actually talking about the limitations of the data, much like I said, look at the key, also look at the title. CO2 emissions per capita in 2007. At this point, 13 years ago. Okay, so this is out of date, too old. Okay, I would generally say you can only say it's out of date if it's 10 or more years old, realistically. Because, say, for example, the census is only carried out every 10 years. So it wouldn't really be fair to say that that was out of date when that's just how often it's carried out. So that's the first thing that I would point out. Next thing is you might have some countries deliberately lying, misrepresenting how much they're emitting, either above or below. So it might be that some countries want to appear like they're more industrialized than they are, so they're emitting lots of CO2. It might be that some want to claim that they're doing better in terms of CO2 reduction than they are, so they might say that they've got much lower figures than they actually have. Some countries are potentially just unreliable in the sense that they don't necessarily have the government or the infrastructure to record the information effectively. So it might be that some LIDCs have unreliable data, not because they're deliberately misrepresenting it, but just because they don't have the facilities to record it efficiently. What is good about this data itself is the source. This is from the UN, so we've got a couple of clues to that data source I've just highlighted. And you've also got where it's come from. It's basically referenced. All very good signs in terms of data. Now, if you were critiquing this and it didn't have those, you could comment that you don't know where the data's come from. That's called not knowing the provenance or the source. And that's generally considered a bad sign. That's why we reference partly, so that I can see that you've collected your data from a valid source as opposed to, just what someone thinks is going to happen or what have you. So these are the sorts of things you can talk about when you actually critique the data. Notice when you critique the data, you aren't commenting on presentation of it, anything like that. Don't make sort of silly comments about, say for example with this, about maybe someone being colorblind and unable to identify the different shades. I mean, that's just not very valid as a point in a lot of these situations. Okay. So at this point, we want to think about how humans impact the carbon cycle. So you can take a moment to come up with some ideas of how humans impact the carbon cycle and how important each one is. So first and foremost, I think close to 90%, 87% of the energy the world produces comes from fossil fuels. So this is being removed from the lithosphere and emitted into the atmosphere, where it's far more potent, has much bigger impact. This is really increased in the last 30 years or so. And the main reason for this is the major industrialization of places like India and China. So their population has increased. Not only that, their population is becoming higher developed. So people are wanting to live a more middle-class lifestyle, eating meat, traveling by vehicle, traveling abroad, much more sort of energy consuming lifestyles than they would have done if they were living sort of in agricultural rural areas, farming, things like that. So 8 billion tonnes of transfer from fossil fuels to the atmosphere each year. So it's a good figure to use, and a further 1 billion tonnes annually through land use change. So we've talked about land use change quite a bit recently. So, and we're now at half the levels of forest cover than we were historically. So some of this carbon that's emitted is then diffused into the ocean. Now this is obviously positive in some ways because it's going to be removing it from the atmosphere and stopping it being a greenhouse gas. But what impact does this have? We've covered this a bit. Well, this acidifies the ocean. And that acidification has negative effects on creatures that live in the ocean. So things like phytoplankton, which are little microscopic creatures that photosynthesize an awful lot, actually, more than the rainforest. It also affects things like corals, things like that. We've also damaged soil greatly. So soil is a living thing. It's got bacteria and organisms in it, and it stores a huge amount of carbon through that. So through deforestation and bad agricultural practices where we overuse the soil, we lead to degradation of the soil. And this releases CO2. We've also damaged wetlands. So a wetland is exactly like it sounds like, it's wet land. So areas like Lincolnshire were very much wetlands, the fens. And if you travel through Lincolnshire, you can see where there's deep ditches where they use those to drain the fields. We also do that in Norfolk, so we've got what we call wind pumps, look a lot like windmills, and those pump water off the fields and stop them from being waterlogged. Well, wetlands again store large amounts of CO2, and so draining them is going to cause that CO2 to be emitted. And this is a kind of a clue as to what we could actually do to help reduce our impact, is if we could reverse these changes, plant more trees, revitalise the soil with better farming methods. This would actually absorb a lot of CO2. So this is a mass balance. So we're comparing inputs into the forest with outputs from it. Okay. So to do this, we need to minus the inputs from the outputs. So the inputs are in blue and the outputs are in pink. So we want to have a go at comparing these two sides. So just notice this is an input for the undisturbed tropical rainforest, and this is the output. This is the input for the deforested tropical rainforest, and then the total output is up here. Just to note, this is tons of CO2 per hectare per year. Okay, so a hectare is 100 meters squared. This is a sort of a unit by which we can measure this. So we need to minus the pink number off the blue number for both sides. So this side is a positive of 5.9, and this side is a negative of 12.8. Okay, so on the left, the undisturbed tropical rainforest is storing close to 6 tonnes of carbon every year per hectare. And on the right, the deforested, even 10 years later, is emitting close to 13 tonnes for every hectare. Okay, so that gives an impression as to the impact that this human activity has. So you have a prediction of what impact is this going to have, what changes is this going to cause, what's the significance of this, okay? So what we want to do to kind of bring all this together is trying to use the information from today, assess the extent to which humans impact the carbon cycle, 10 marks. So this requires a bit of being evaluative, a bit of discussion. 2 peel structure paragraphs should do it, I would think, 2 kind of well-developed ones. So for each one, consider the impact that is being had, provide data to explain that, explain the impact that's being had, and evaluate the significance of it. Okay, so have a go at doing that using the information that we've done today. That's on page 131 to 133 of the textbook to look at the impacts that are being had.